राइट गाइस, आज शुरू करते हैं। हाइड्रोकार्बन्स कंटिन्यू करेंगे कंट्रोल्ड ऑक्सीडेशन से। 24 Feb। लेट्स स्टार्ट। कंट्रोल्ड ऑक्सीडेशन। सॉरी, controlled oxidation. Alkanes on heating with regulated supply of dioxygen or air at high pressure and in the presence of suitable catalyst have a variety of oxidation products. For example, 2-methane plus O2 in presence of copper at 523 Kelvin and 100 atm pressure will give 2-methanol. Methane in presence of oxygen, nahi, reaction with oxygen in presence of molybdenum oxide will give क्या कहते थे CH2O, भूल यार, मिथेनॉल। मिथेनॉल एंड वाटर, कीटोन भी तो कहते थे। इथेन प्लस ऑक्सीजन इन प्रेजेंस ऑफ manganese acetate will give CH3COH ethanoic acid plus water। मतलब ये एसिड दे सकते हैं, क्या कहते थे, अल्कोहल दे सकते हैं और एल्डिहाइड्स दे सकते हैं और कीटोन दे सकते हैं। Ordinary alkanes resist oxidation, but during alkanes having tertiary hydrogen atom can be oxidized to corresponding alcohols by potassium permanganate. Okay, ICH3, I क्यों है? CH3 whole thrice, CH in presence of KMnO4 oxidation होगा उसका, और C double bond OH लग जाएगा, COH लग जाएगा, अल्कोहल बन गया। Isomerization. An alkane on heating in the presence of anhydrous aluminum chloride and hydrogen chloride gas isomerize to branch chain alkanes. Major products of the are given below. Some minor products are also possible which you think over. Minor products are generally not reported in organic reaction. So n-hexane से 2-methyl pentane और 3-methyl pentone। कौन इन क्यों आ गया यार, यहाँ पे पेंटेन ही तो होगा। ये नहीं मान रहा भाई। Aromatization. N alkanes having 6 or more carbon atoms on heating to 773 Kelvin at 10 to 20 ATP in the presence of oxides of vanadium, molybdenum, or chromium supported over alumina or alumina gets dehydrogenated, cyclized into benzene and its homologue. This reaction is known as aromatization or reforming. Okay. Toluene C7H8 is methyl derivative of benzene. Which alkenes do you suggest for preparation of toluene? Heftane. Reaction with steam. Methane reacts with steam at 1273 Kelvin in the presence of nickel catalyst to form carbon monoxide and dihydrogen. This method is used in industrial preparation of dihydrogen gas. Okay. Pyrolysis. Higher alkanes on heating to higher temperature decompose into lower alkanes. Pyrolysis, lower alkanes. Lower alkanes, alkenes, etc. Such a decomposition reaction in the smaller fragment by application of heat is called pyrolysis or cracking. So C6H4, that is again at 773 Kelvin, will give this hydrogen with this basic and the following. Pyrolysis of alkanes is believed to be a free radical reaction. Preparation of oil gas or petrol gas from kerosene oil or petrol involves the principle of pyrolysis. For example, 2-decane, a constituent of kerosene oil on heating to 973 Kelvin in the presence of platinum, palladium, nickel gives a mixture of heptane and pentane. 2 डेकेड मतलब 20 कार्बन 12 हो गया है सॉरी C12H26 in presence of platinum, palladium and nickel will give heptane and pentane plus other products. The third. Conformations. Alkanes contain carbon sigma bond. Electron distribution of sigma molecular orbital is symmetrical around intermolecular axis of C bond, a single bond. This rotation results in different spatial arrangement of atoms in the space, which can change into one another. The spatial arrangement of atoms, which can be converted into one another by rotation of carbon-carbon single bond, is called uh, conformations or conformers or rotamers. Alkanes can thus have infinite number of conformations by rotation around CC single bonds. However, it may be remembered that rotation around CC single bond is not completely free. It is hindered by a small energy barrier of 1 to 20 kilojoules due to weak repulsive interaction between the adjacent bonds. Such a type of repulsive interaction is called toroidal strain. Conformations of ethane. Ethane molecule C2H6 contain a carbon-carbon single bond in which each carbon atom attached to three hydrogen atoms. Considering the ball and stick model of ethane, keep one carbon atom stationary and rotate the other carbon atom around CC axis. This rotation results in infinite number of spatial arrangement of hydrogen atoms attached to one carbon atom with respect to the hydrogen atom. Hydrogen atom attached. This rotation results into infinite number of spatial arrangement of hydrogen atom attached to one carbon atom with respect to the hydrogen atom attached to other carbon atom. These are called conformation isomers or conformers. Thus, thus there are infinite number of conformations of ethane. However, there are two extreme cases. One such conformation in which hydrogen atom attached to a carbon are as close together as possible is called ellipse. दोनों बिल्कुल साथ में हैं. This one वाला फिर ellipse conformation. And the other in which hydrogen are as far as possible. Uh, this is called staggered conformation. Any other intermediate conformation is called skew conformation. It may be considered that all the conformations, the bond angles and the bond length remain the same. Ellipse and staggered conformation can be represented by Sohorst and Newman projection. Newman हो गई तो Sohorst projection. This projection, the molecule is viewed along the molecular axis. It is then projected on paper by drawing the central C bond as a somewhat longer straight line. Upper end of the line is slightly tilted towards the right and left hand side. The front carbon is shown at lower end of the line, whereas the rear carbon is shown at the upper end. Each carbon has three lines attached to it corresponding to three hydrogen atoms. The lines are inclined at an angle of 120 degrees. So horse projections of ellipse and staggered conformation are depicted. Newman's projection. In this projection, the molecule is viewed at the CC bond head-on. The carbon atom nearer to the I is represented by a point. Three hydrogen atoms attached to the front carbon atom and are shown with three lines at an angle of 120 degrees from each other. The rear carbon atom away from the is represented by a circle, and the three hydrogen atoms are shown dashed to it by a shorter line, shown at an angle of 120 to each other. When projection of ethane is given in figure diagram. The relative stability of conformation. As mentioned earlier, In staggered form of ethane, the electron clouds of carbon and hydrogen bonds are as far as possible. Thus, there is minimum repulsive force and maximum stability of the molecule. On the other hand, when the staggered form changes into eclipse form, the electron clouds of the carbon-hydrogen bond come closer to each other, resulting in increase in electron cloud repulsion. To check the increased repulsive forces, molecules will have to possess more energy and thus have lesser stability. As already mentioned, the repulsive interaction between the electron clouds, which affects stability of a conformation, is called toroidal strain. Magnitude of toroidal strain depends on the angle of rotation about CC. This angle is also called dihedral angle or toroidal angle. Of all the conformations of ethane, the staggered one has the least toroidal strain, and the ellipse form has maximum toroidal strain. Therefore, staggered conformation is more stable than ellipse conformation. Hence, molecule largely remain in staggered conformation, and we can say that it is preferred conformation. Thus, it may be inferred that the rotation around CC bond in ethane is not completely free. The energy difference between the two extreme forms are are of the order of 12.5 kilojoules. It is very small. Even at ordinary temperatures, the ethane molecule gains thermal or kinetic energy sufficient enough to overcome the energy barrier of 12.5 kilojoules through intermolecular collision. Thus, it can be said that rotation about carbon-carbon single bond in ethane is almost free for all the practical purposes. It has not been possible to separate and isolate different conformational isomers of ethane. Alkenes. Alright. Alkenes are unsaturated hydrocarbons containing at least one double bond. But what should be the general formula of alkene? If there is one double bond between two carbon atoms in alkene, they must possess two hydrogen atoms less than alkene. Hence, general formula for alkene is CnH2n. Alkenes are also known as olefins or oil forming, since the first member, ethylene or ethene, are found in the form of oily liquid on reaction with chlorine. The reaction. Structure of double bond. Carbon-carbon double bond in alkenes consists of one strong sigma bond enthalpy about 397 kilojoule per mole due to head-on overlapping of sp2 hybridized orbital and a weak pi bond enthalpy about 284, almost 113 kilojoule, obtained by lateral or sideways overlapping of two 2p orbitals of the two carbon atoms. The double bond is shorter in bond length, 134 picometer, than carbon-carbon single bond, that is 154 picometer. You have already read that pi bond is weaker due to the poor sideway overlapping between two 2pi orbitals. Thus, the presence of pi bond makes alkenes behave as a source of loosely held mobile electrons. Therefore, alkenes are easily attached by reagents or compounds which are in search of electrons. Such reagents are called electrophilic reagents. Yeah, in mobile electrons. The presence of weaker pi bonds make alkenes unstable molecule in comparison to alkanes, and thus alkenes can be changed into single bond compounds by combining with electrophilic reagent. Strength of the double bond enthalpy 681 kilojoule is greater than that of carbon-carbon single bond. The bond enthalpy that is 348 kilojoule per mole. Orbital diagram of ethane is shown below. Ethene होना ethene है हाँ. Two Nomenclature. For nomenclature of alkenes in IUPAC system, the longest chain of carbon atom containing the double bond is selected. Numbering of the chain is done from the end which is nearer to the double bond. The suffix "ene" is replaces "ane" of alkene. Is- It may be remembered that first member of alkene series is CH2 uh, replacing N by 1 CnH2n, known as methene, but has very short life. As already mentioned, first stable structure of alkenes series is C2H4, that is ethene or ethylene. Few member of alkenes are given below: propene, butanene, butene, butadiene, buta 2-methyl propanene, where 3-methyl butanene, and so अब इसमें आएंगे हम इस एंगल भी देख लेते हैं ये राइट का होता है bond length और bond angle. CH HCH HCH का bond angle 116 और HCC का bond angle 121, जो कि ज़्यादा होगा, और bond length CH bond की 110 और CC bond की 134 डबल बॉन्ड के कारण कम होगी. Alkenes show both structural isomerism and geometrical isomerism. Structural isomerism, as in alkanes, uh, ethene C2H4 and propene C3H6, can have only one structure, but alkenes higher than propene have different structures. Alkenes possessing C4H8 as a molecular formula can be written in the following ways: butanene, butuene, 2-methylpropanene. Structure 1 and 3 and 2 and 3 are example of chain isomerism, whereas structure 1 and 2 are position isomer. Geometrical isomer. Doubly bonded carbon atom. Uh, Doubly bonded carbon atoms have to satisfy the remaining two valence by joining with two atoms or groups. If यार पानी पी लो. If the two atoms or groups attached to each carbon atom are different, they can be represented by YX C double bond C XY. Like structure and YX C double bond CXY can be represented in space in the following two ways. ये हो गया cis, ये हो गया trans. In A, the two identical atoms like X or both Y lie on the same side of the double bond, but in B, the two X and two Y lie across the double bond or on the opposite side of the double bond. This results in different geometry of A and B, that is, this position of atoms or groups in the space in the two arrangement is different. Therefore, they are stereoisomers. They would have same geometry if atoms or groups around C double bond C can be rotated, but rotation around C double bond C bond is not free. It is restricted for understanding concept is restricted. For understanding this concept, take two pieces of strong cardboard and join them with the help of two nails. Hold one cardboard in your hand and try to rotate the other one. Can you really rotate the other cardboard? No. The answer is no. The rotation is restricted. This illustrates that the restricted rotation of atoms or groups around the doubly bonded carbon atom give rise to different geometries of such compounds. The stereoisomerism of this type is known as geometrical isomerism. The isomers of type A, in which two identical atoms or groups lie on the same side of the double bond, is called isomer, and the other of the type B, in which the identical atoms or groups lies on the opposite side of the double bond, is called trans isomer. The cis and trans isomers have same structure but have different configuration or arrangement of atoms or groups in space. Due to different arrangement of atoms or groups in space, these isomers differ in the properties like melting point, boiling point, dipole moment, solubility, etc. Symmetrical or cis-trans isomers of butene are given below. This form of alkene is found to be more polar, okay, more polar, मुझे पता है, but for example, dipole moment of cis to butene is 0.3 by and dipole moment of trans form is almost zero. So it can be said that trans butene is nonpolar, whereas this can be understood by drawing the two form the given forms as given below, from which it is clear that in trans butene the two identical methyl groups are in the opposite direction. Therefore, the dipole moment of CS3 bond cancels, thus making trans nonpolar. In the case of solid, it is observed that trans isomers have a higher melting than cis. Symmetrical or cis trans isomers types of IC6Z collaborative. यार मेरा एक मिनट आता हूँ कर 1 minute 1 minute please. Right guys, वापस sorry वो delivery. Okay, let's continue. So preparation from alkynes. Alkynes on partial reduction with calculated amount of dihydrogen in the presence of palletized charcoal, partially deactivated with poisons like sulfur compounds or quinolone, give alkanes. Too many things. Partially deactivated palletized charcoal is known as Lindelar catalyst. So, the alkenes thus obtained are having cis geometry. However, alkynes on reduction with sodium in liquid ammonia give trans pure ammonia. Sorry, मेरा तो अभी अलग अलग दिए हुए हैं प्रोपीन के विल प्रोपीन obtained show geometry नहीं करेगा दो सेम है from alkyl halides. Alkyl halides RX on heating with alcoholic potash or potassium hydroxide dissolved in alcohol, say ethanol. Eliminate one molecule of halogen to form alkenes. This reaction is known as dehydrohalogenation, that is, removal of halogen acid. This example of beta elimination. This is example of beta elimination. Since hydrogen atom is eliminated from beta carbon atom next to the carbon which is halogenated. Nature of halogen atom and the alkyl group determine the rate of the reaction. It is observed that for halogen, the rate is iodine rather than bromine chlorine, while alkyl group is tertiary, secondary and primary. वैसे क्योंकि आयोडीन बड़ा है तो साथ के साथ चीजें होता है. From vicinal dihalides. Dihalides in which two halogen atoms are attached to two adjacent carbon atoms are known as vicinal dihalides. Vicinal dihalides on treatment with zinc metal lose a molecule of ZnX2 to form alkenes. Okay? This reaction is known as dehalogenation. तो डाइहैलाइड रिएक्टर ZnBr2 गया और एल्कीन बन. सिमिलरली यहाँ पे प्रोपीन के लिए from alcohols by acidic dehydration. You have read during nomenclature of different homologous series, Unit 12, that alcohols are the hydroxide derivatives of alkane. They are represented by ROH, where R is CnH2n plus 1. Alcohols, on heating with concentrated sulfuric acid, form alkenes with the elimination of one water molecule. दोबारा पढ़ता हूँ. Alcohols on heating with concentrated sulfuric acid form alkenes with the elimination of one water molecule. Dehydration होगी. Since a water molecule is eliminated from the alcohol molecule in the presence of acid, this is known as dehydration of alcohol, acidic dehydration of alcohol. This reaction is also example of beta elimination reaction, since OH group takes out one hydrogen atom from the beta carbon. Alpha, beta, water गया. तो properties खत्म कर दूंगा यार आज. ठीक है. अरे नहीं होगा खत्म. हाँ होता करते हैं. Properties, physical properties. Alkenes as a class resemble alkanes in physical properties, except in the type of isomerism and difference in the polar nature. The first three members are gases, the next 14 are liquids, and the higher ones are solids. The ethene is colorless gas with faint sweet smell. होती है. All the other alkenes are colorless and odorless, insoluble in water but fairly soluble in non-polar solvents like benzene, petroleum, ether, etc. एक ही चीज है. Petroleum is a. They show a regular increase in boiling point with increase in size. That is, every CH2 group added increases the boiling point by 22 Kelvin. Chemical property. Like alkanes, straight chain alkenes have higher boiling point than isomeric alkenes. करेगा electron. Alkenes are rich source of loosely held pi electrons, due to which they show addition reaction, in which the electrophiles add on to the carbon-carbon double bond to form addition product. Some reagent also add by free radical mechanism. There are cases when under special condition alkenes also undergo free radical substitution. Oxidation and ozonolysis reaction are quite prominent for alkenes. A brief description is of different reaction of alkenes. Reactions कल से शुरू करेगा. ये वाला पार्ट पढ़ लो. Alkenes reaction. Addition of dihydrogen. Alkenes add up one molecule of dihydrogen gas in the presence of finely divided nickel, palladium, or platinum to form alkane. Addition of halogen. Halogens like bromine or chlorine add up to alkenes to form vicinal dihalide. However, iodine does not show the following reaction under normal conditions. The reddish orange color of bromine solution in CCl4 carbon tetrachloride is discharged when bromine add up to the unsaturated site. This reaction is the test for unsaturation. Reddish orange color of bromine is when adds up to unsaturated site. and this is test of unsaturated. Addition of halogens to alkene is an example of electrophilic addition reaction involving the cyclic aluminium ion aluminium formation, which you will study in higher classes. In plus Br2 in presence of CCl4 will give 1,2-dibromoethane. Similar for protein will give 1,dichloro. Addition of halogen halides. Hydrogen halides. Hydrogen halides HCl, HBr, Hi add up to the alkene to form alkyl halides. The order of reactivity of hydrogen halide is Hi more than HBr is more than HCl. तो बड़ा होता है ऐसे तो जल्दी बहुत होता है. Like addition of halogens to alkene addition of hydrogen halide is also an example of electrophilic addition reaction. Let us illustrate illustration वाला पार्ट कल से शायद 2 दिन और लगेंगे चैप्टर पे हो जाएगा. तो मिलते हैं बस कल. अब कल भी 10 बजे करूँगा, अब फिर रोज 10 बजे स्ट्रीम किया करूँगा. तो थैंक यू गाइस फॉर वॉचिंग. मैं कल सुबह ऑल्सो मैं वैसे रेगुलरिटी मेंटेन करने के लिए कर रहा हूँ अभी, ताकि मैं रोज करता पढ़ता रहूँ. बाय बाय.